HSRP interface tracking. This is a great little feature, and what it does, it enables HSRP to monitor an interface that you and I as the network admins specify, and the status of that interface will dynamically change the HSRP priority for a specified router for better or for worse, and let's find out which one that's going to be. When that tracked interface's line protocol goes down, the HSRP priority of the router is decremented. Of course, a fancy way of saying it goes down. Now, this can lead to another HSRP router in the group becoming the active, but that other router must have preemption enabled. Now, in this diagram, I have not indicated or not put the virtual router in there. We know it's in there, and we're actually going to configure that, because I've got these IP addresses, the interface VLAN 100, but that's it. So we're doing everything else from scratch in this lab. And what we're going to do is set MLS 2 up with a priority of 105. It should, of course, become the active because it's going to have a higher priority than 1, which we're going to leave at the default priority of 100. Well, as a result, then 2 will handle all the traffic sent to the server behind MLS 1 and 2 here. You can tell it's a very important server because I put a giant bag of money next to it. Well, there's nothing really wrong with that, but there is a single point of failure, and it might not be the one you're thinking about that could cause some trouble. And again, the IP addresses shown for the multi-layer switches in this lab are for their SVI for interface VLAN 100. The problem here is that if Fast Ethernet 3 on switch 2 fails, the hosts in VLAN 100 can't get to the money bag server or whatever server we've got back there. But by default, that Fast Ethernet port going down is not going to affect HSRP in any way. It's not going to bother it at all. So what we're going to do is change that default a little bit and put some tracking on there. First, we're going to go ahead with a configuration, but first, I've got something here to show you. On switch 2, I've got show interface Fast Ethernet 3. Save yourself a lot of time and agony when you're configuring HSRP interface tracking. Always check the status of the interface before you even start, because if there's something wrong with this interface and you don't realize it, then you're going to get some comeback or some feedback from your show commands in HSRP that you're not expecting, and you end up troubleshooting your HSRP config because that's the last thing you did when the actual problem was the interface you were tracking was down already. Not that that ever happened to me. I just heard it, from a guy, so I'm sharing it with you. Okay, I'm lying. It did happen to me. Not here, but I did learn that lesson the hard way. Let's go ahead and get started with our basic config. We'll go with standby group 1 this time. 12. I try to put 12 in there. 16, 23, 12. And we're going to set the priority to 105 there, and that's going to be it. And that's it. So right now on switch 2, use the standby IP command to enable HSRP, create our virtual router. Then I set it with a priority of 105, interface VLAN 100. I enabled HSRP, same address, of course, same virtual router, and enabled preemption. So let's go forward. Let's take a look at 6s here and just make sure. At switch 2, and you can see you've got a couple things, all of which we really expect to see. There's VLAN 100 group 1 state is active, preemption disabled by default, active router is the local, standby router is 23.1, and there's priority 105, and of course it says configured 105 because we put that in there. Let's go back to switch 1 for a moment. Run the exact same command, and we see what we expect to see, that the state is standby, preemption is enabled, active router is 23.2, there's that router's priority, our standby router is the one we're on, and our priority is 100, and it even says default 100, which of course your switch and then your T-shoot exams are not going to tell you, so that's another great value to have absolutely memorized. We got another one coming up as well. So let's go ahead and start with our interface tracking, and I'm going to hop over to switch 2 to get that done. Let me show you this command. Interface VLAN 100, it's standby 1, and what we're doing here is tracking. They call it priority tracking That's fine with me. I don't care what you call it, as long as you know how to do it. So we're going to use track here, and then we got a huge list of interface types, plus a tracked object number. We're not getting into the numbers here in your CCNP studies. We're going to stick with the interfaces. So we're going to put fast Ethernet, maybe 0/3. And we have a decrement value of 1 through 255, but we can also just enter the command as it is. So what could be that decrement value? That default is 10. That's another really good value to have memorized. So everything being equal right now with what we've put in, switch 2 has a priority of 105, switch 1 a priority of 100. So if we decrement switch 2 by 10, and we have preemption enabled on the router we want to take over, in case this interface goes down, then we should be set. So let's go ahead and go with that default. Then we're going to go to that interface and we're going to bring the line protocol down because we're going to shut the interface. And we get all kinds of messages right away. One that we haven't seen before. Notice the top line, the top log message, I'd say the console message, tracking 5 state, 1 interface fast 03, line protocol up to down. Then all kinds of other things happen. Right after that tracking message, there's the one we hadn't seen before. Here's your HSRP state change message. We went from active to speak immediately. Then we get the usual messages we expect to see when we shut an interface down, change state to administratively down, line protocol, change state to down. And this all happened in about a 3-second period. Then 12 seconds after we shut that interface down, the local interface has gone from speak to standby, the local switch, I should say. So let's do show standby, and we'll see the aftermath of what we did. You can see that priority 95 configured 105, so something made it go down, and certainly we know what it is. And here it is, right in show standby. Track interface fast Ethernet 0/3, state is now down, and it decremented by 10. And we see also the state is standby. Let's go over to switch 1. Pretty much know what we're going to see here, but we're going to run it anyway. And you can see now it is the active. Active router is local. Standby router is 23.2, which is .2. And it even shows you now that switch 2's priority is 95. So that's pretty cool. Now, the obvious question is, what do we have to do as network admins when switch 2's interface comes back up? You know, is the cutover going to happen immediately? Do we have to do something else? What do we got to do? Well, there's only one way to find out, by golly, and let's do that. We're going to reopen that interface. And let's see what our console messages are this time around. Okay, we've got a tracking state message in there. So the interface went down physically right after we did that with a nose shut. And then here's your tracking state. It's already detected the line protocol's gone up. It even gives you the direction. Can't beat that. Down to up. So then we get the usual interface change state to up. Then the line protocol went up. What aren't we seeing here? We aren't seeing a message about this router becoming the active. It didn't even change any states. It just noticed, hey, I'm tracking this interface and it's gone up. But nothing else happened. Is that a problem with the log messages, you think? Console messages? Let's take a look. Well, the active router is still 23.1, and we're still the standby router, even though the priority went up correctly. So tracking seems to be working fine. And here it even says track interface fast Ethernet 0/3, state is up, decrement is 10. What is going on here? Why isn't switch 2 taking over as the active? The answer is right in front of you. Preemption disabled. If we want this router to take back over as the active when that interface that we're tracking comes back up, and we probably do, then we have to enable preemption here as well. Always watch preemption. There's a reason I'm hitting you over the head with it. And I'm not going to put anything else in, and you can see immediately we get a state change from standby to active, and now everything that we wanted to have happen router, excuse me, switch 2 going back to being the active seems to have happened. Yep, there you go. So active router is local, standby is 23.1, priority 105. The tracking information is correct. There is the key right there, preemption enabled. That is the key. If we want that router to become the active one again once the interface is fixed, and again we probably do or we wouldn't have made it the active in the first place, then we've got to enable preemption. Before we move to the next lab, I know another question that's likely on your mind now. It's like, well, should I just always enable preemption? You know, when I'm doing HSRP, should I always enable preemption? Of course, there is no one-size-fits-all answer to that question. Some people think it's a little bit of a security hole. I'm not really on that side, but it just depends on what your deployment is. It's not something I would just automatically put every single time on every single router, because of course you could have multiple switches in there in your group and you say, well, here's one I really don't want to become the active. So it's not something I would just do blindly, but I would just analyze your network, take a look at it. You're a CCNP, you look at it and say, here's where we need it and here's where we don't. But I would not just blindly enable it every time. On your exam and in your lab and on job interview questions and in the workplace, the first thing I look for when I'm not seeing the kickover that I expect to see with tracking is making sure preemption is enabled on the switches that need it. So let's see, we're hitting about 11.5 minutes on this video. We're going to go ahead to another video, and I am going to reset the switches. We're going to do another tracking lab, and then I've got some other great labs for you right after that. So I'll see you in the next video.